In this video, we're going to discuss the acid hydrolysis of an amide. Now, the interesting thing is the mechanism is essentially identical to the acid hydrolysis of an alcohol. The difference is amides are much more stable than alcohols. This is a secondary amide. It's quite stable, more stable than a primary amide, a lot more stable than an alcohol. This means if we do the hydrolysis, we have to use concentrated acid and we have to heat it up. So I flagged this with both concentrated and heat to show those two things. But otherwise, the mechanism is very similar to that of an ester. So what do? We start by protonating the carbonyl. We take our protonated carbonyl and attack it with a water molecule. So get a water molecule and do a simple attack on the carbon of what was originally the carbonyl, push the double bond out onto the oxygen, and get our product. So here's our tetrahedral intermediate. Now we just have to do the internal transfer of the proton, have the amine reach over, grab the hydrogen on the water molecule. Just move this a little bit, have this come around here, and draw another arrow, the little arrow, back to the oxygen. So we're just doing the proton transfer. At this point, it's time to kick out the amine, and we have two OH groups. We can use either one of them. It doesn't matter. Let's use this one. Oops, sorry. But there, and which will kick out the amine. This will give us our protonated product. So this is our protonated carboxylic acid. All we have to do is to lose the proton on the carbonyl, and we're finished. So this is the acid hydrolysis. Now, if it's a tertiary amine, it really starts to get difficult. You're probably going to have to, you're actually doing the lab, you'd probably have to use concentrated acid, lots of heat, and lots of time. But it will work.